Okay, let me focus here also. We are doing 6.1 and 6.2. It's one section. They're just lumping it together in the homework in my math lab. Matrix solutions to linear systems. There's no skill in here you haven't already done. It's just put together a little differently. So, any questions before we get started? Anything on your mind that we need to look at? I thought I was done. Yeah, I'm done with 5.5. 5.4, I had 2 extras that I covered. Yeah, and you asked that question on Wednesday, Chloe, if I was going to cover the extra 2 from 5.4, the one on logs and the one on something else. Oh, yeah, the perimeter and area of a rectangle. And so I think maybe you're just getting that confused with 5.4. So we did cover those. We've done all of 5.5. If I'm wrong, let me know, and I'll do that on Wednesday. Thanks. Okay, anybody else? Anything on your mind, on your brain? Okay, let's get going. We are looking at 6.1, 6.2, matrix solutions to linear systems. The method we're going to use is Gaussian elimination with back substitution. That's its name. Gaussian you need to worry about. Here's the deal. Let's look at one. The first thing I want to look at here is we are used to 11x plus 12y plus 9z equals 11. And we might have a 5x plus 9z equals 2, and a 6x plus 4y plus 8z equals 2. We might have a system of 3 equations in 3 variables that we worked with, where we tried to eliminate by adding, like maybe we could take care of those 9s, multiply the second equation times a -1. Or let's say we've got this already in 2 variables, so we've got a keeper equation. Let's work with the first and the third one to make another keeper. That routine. That's just solving system of 3 equations in 3 variables. Now we're going to do the exact same thing, but by a different method. Instead of doing elimination, addition elimination, to get it down to 1 variable and then work our way back up, we're going to use a matrix solution. So we're going to go about doing the same exact thing that we've been doing, but with Gaussian elimination with back substitution. So the first thing we need to do is get this thing prepared, and that's the first question you're going to have. You're going to be asked to find the augmented matrix. Augmented matrix. And here's what we're going to do. I'm going to put that in a little box. I'm going to put a line there. And I'm going to put the coefficients for each of these. 11, 12, 9, and then the answer equals goes over here. 5x, 5 goes in the x column. We don't have a y, so I'll put a 0 here. You've got to fill in with zeros when you don't have somebody. And then a 9 right there. And then the answer goes there. And then put in the coefficients, 6, 4, 8, and then 2 is the answer. So there's an equal sign right here that you know about. Okay, this is called the augmented matrix, and that's what our problems are going to look like. What we're going to do is we're going to create a 1 right there instead of that 11. And then we're going to create zeros down here. That'll be our first line, 1, 0, 0. And I know the end result doesn't, you don't know what we're doing. Don't worry. This is step by baby step here today. I love the presentation of this. I've reordered a little bit to make, to do a better job of process, I hope. But anyway, this is our beginning. This is our augmented matrix. This is where we will start. And our goal will be to create a 1 and then create zeros here. And we'll look at what we're going to do in just a minute, of course, we will. Okay, let me give you an augmented matrix. And you turn it into this old-fashioned kind, 3 equations in 3 variables. So let's look at 4, 0, 3, -17. 0, 1, negative 6, 14, and then 9, 7, 0, 2. Okay, that's a 2 right there. That's order. Okay, turn this into this sort of statement. Let's just translate this back so we have some sense of what we're doing. So this will be 4x. There isn't a y, and we wouldn't include it in our normal situation, but we would leave it blank. Plus 3z equals negative 17 for the first line. And then the second line, there isn't an x, so we'd scoot over and put y, or you could put 1y. That wouldn't be the worst thing in the world. Minus 6z equals 14. And then 9x plus 7y, leave z blank, equals 2. And that's the sort of 3 equations in 3 variables translation from this augmented matrix, which we will do Gaussian on. We'll do Gaussian elimination. It's looking at you like that. We'll do Gaussian, where we'll get a 1 there. Oh, cool, there's already a 0 there. And we'll get a 0 there eventually. Okay, next I want to just do one more time and give you 2x minus y plus 9z equals negative 6. And then 4x minus 6y equals 4. And 9x minus 2z equals negative 8. There's 3 equations in 3 variables. See what you can do about turning that into an augmented matrix. I'll give you a minute over here. Be sure to column them up and throw in zeros where zeros need to be put. Okay, hoping yours looks something like that. You need a 0 in the z position in the second equation. You need a 0 in the y position in the third equation. So it needs to look like that. And again, we're going to eventually have a 1 right there and zeros here. And then on this row, we don't really care what's happening here, but we're going to get a 1 right there and a 0 right there. That's cool. And again, we don't care what's happening there, but we'll want a 1 there. Let's look at why that is. This is what this is what our goal is. We want to have like something like 1, negative 2, 0, 2, 0, 1, 1, 7, 0, 0, 1, 4. Okay, this is an example of what you could end up with. You would be done at this point. And we're gonna finish this off. So this is what our goal is, to have a 1 right there and zeros in the rest of the column. And then a 1 right here and a 0 underneath him, and a 1 right there. Let me mark that column there, this diagonal column of 1s right there. That's important that you've got 1s diagonally down. We'll talk about why. We're going to finish this off so you can see what the goal is and why the goal is that. And then zeros here. It doesn't matter what's happening up in here. These don't matter. These 3 don't matter. These are answers, so they really don't matter. But you want 1, 0, 0, 1, 0, 1, a diagonal 1 with zeros underneath those 1s. Okay, let's look at what that says. Let's translate that back. This will say x minus 2y, no z, equals 2. This line, let's make this something. Let's make this be a 10. just because, although that's going to mess everything up, but that's okay. We'll worry about it later. So let's say this is x minus 2y plus 10z equals 2. I just randomly changed that because I want a z in that position. I don't want weird situations for you first time you look at this. Then next we have no x. We have y plus z equals 7. And then here we have no x, we have no y, but we have a z equals 4. There's what we've got from our augmented matrix here that we have done Gaussian elimination. That's the 1, 0, 0, 1, 0, and 1 thing. So here's where we are. Look, we have one answer. Then we can plug that up into there and say y plus 4 equals 7. So y equals 3. And then we can plug in the fact that 3 is y and z is 4 into this top equation. X minus 2 times 3 plus 10 times 4 equals 2. And we'll eventually get an x equals, let's see, that's going to be x minus 6 plus 40 equals 2. X plus 34 equals 2. So x equals negative 32. So there's our x, y, z. That's our 3 answers in 3 variables. So our answer to this one would be negative 32, 3, 4. That's our answer in x, y, z. So rather than multiplying entire equations times, a way to cancel out stuff, we do it differently. We're doing the same sort of thing. And this is what we're going to get. We're going to move from something like this, where we've got a hodgepodge, down to 1, 0, 0, 1, 0, 1. These have to be 1s. We'll have to create a 1. We'll have to create zeros. We'll have to create a 1 and create a 0, and then finally create that 1. And we will end up then translating this back into XYZ format. This will be z equals, because this is going to be no x's, no y's, but z equals 4. That says 1z equals 4. Then we'll have that 1. We'll be able to go back to where there are 2 variables and plug in our z to get y, and then we'll be able to go back up to 3 variables with a z in hand and a y in hand and plug that in. So that's where we're going. We're going to, if we're given this, we'll translate it into the augmented matrix, and then we're going to create a 1, 0, 0, 1, 0, 1 pattern, diagonal ones with zeros down here, and nobody cares what's going on up there. All right, let's do a baby step of that. Let me show you one, and let's take the first 3 steps. We won't finish this one because it doesn't work out nicely, but I want to do just a couple of steps so you get the idea. 7, negative 14, 21, negative 28, negative 8, 9, 2, 0, and 6, 0, 8, 11. So there's our augmented matrix. We've pulled out the x, the y, and the z, and the equal signs. And now what we want to do first is create a 1 right there. So to create a 1, and we'll be creating a 1 a ton of times, that's a 1-step process. What you're going to do is multiply by the reciprocal. And you can do that. I mean, you can figure out what a reciprocal is and you can multiply by it. So let's do that. We want to create a 1 right there. That number is 7. Its reciprocal is 1/7. So up here on the top line, I'm going to write 1/7 row 1. That tells me I'm going to multiply this entire row times 1/7 times the reciprocal of where I want to create the 1. And if you multiply one of the variables times 1/7, you've got to multiply everybody times 1/7. That's how that works. So what's going to happen here is I've put this on row 1 because that's the only row that's going to change. I'm only doing an action to the top row. Use your calculator here, although this is not difficult. This is not tricky, but if you're like, I'm over fractions, then don't do it that way. Do it this way. So 7 times 1 ABC 7, because we're multiplying times 1/7, equals 1. That's what we need. We need a 1 in this upper left-hand corner. Oh, and by the way, since we're messing with row 1 only, row 1's the only one that's going to change. I'm going to go ahead and write everything else back in here. These are not going to change. Only one row changes at a time. So those guys, put them in there. Let's go through and complete multiplying row 1 times 1/7. So this will give me a -2. This will give me 3, and this will give me -4. And let me just do that last one for you in case that's confusing to you. -28, put in negative using this bottom key here for the negative, 28 times 1 ABC 7, because you're doing a fraction, equals, but it's just 7 goes into 28, that's all we're doing. Okay, we have created a 1 right here, and that's good. That's what we wanted. Next thing we want to do is create a 0 in these positions down here. We'll do it one at a time. So let's create a 0 here. So to create a 0, that's a two-step process. Two-step process. We're going to multiply the 1 line, and I put that in quotes. That's supposed to be quotes. That's kind of sorry looking quotes. Looks sort of like a 4. It's not. Multiply the quote 1 unquote line by the opposite of the coefficient and add. Okay, we're going to do this multiple times today. You will get the use. This is all we're going to do. And we're going to do completely, we're going to do 4 of them, not 3 of them really. And this is just a starter. This is just getting your feet wet. So to create a 0, we want to create a 0 right here. We're going to multiply the 1 line by the opposite of that coefficient. So I'm going to say 8 times row 1. That'll make that an 8. And then I'm going to add it to row 2. So I'm multiplying the 1 line by the opposite of that coefficient. So they'll cancel. We've done that. We did that in the previous sections. Multiply this line times 8 to add it up there to kill the x's. We're trying to kill the x's here, trying to make that a 0. So I wrote it here like this, and there are lots of ways they show it to write. I'm the only one doing this in 2 rows. I want to multiply 8 times row 1. And I know it says row 1. I could put it over, across the room, and it still says row 1. But if I put it on row 1, then I'm reminded that I'm multiplying that one times 8. And then I'm adding it to this one, adding it to row 2, and I'm putting it on row 2. The last thing that's written was on row 2. So that means row 2 is going to change. Nobody else will change. So I'm going to put my other numbers in there. I'm going to fill in row 1 and row 3. They won't be changing here. Only row 2 will change. I want to change this to a 0, and this is the only row that will change on this step. So let's do this. 8 times row 1, that's 8 times 1 plus -8. Sweet, got my 0. Remember, I'm going 1, 0, 0. Let's keep going. 8 times this, 8 times -2 is -16 plus 9. -16 plus 9 is -7. Use your calculator if you're not comfortable doing this in your head. You cannot afford to make a mistake here. These are dinky little problems. This is 8 times 3 is 24, plus 2 is 26. But if you make any kind of mistake here, I mean, you cannot be planning lunch while you're doing these. If you are distracted, stop doing these. They're just going to be nothing but frustration for you. And then 8 times -4, 8 times row 1, that's -32 plus 0. So we get -32. Okay, I am not going to try to write in here what we're going to do and then do it over here. I can do that, but this is your first time through. My guess is you will continue to have to rewrite this on the next line. So let's see, 1, -2, 3, -4, 0, yay, we've got that 0 in place. -7, 26, -32. When you need help on this, when you have done this and you cannot find your mistake, but you know you've got a mistake, send me this so I can see what you did. And I can promise you, it's very difficult to find your own mistakes. To look at this and say, okay, did I make a mistake here? Did I make a mistake here? To start over. If you're trying to repair something, don't try to find your mistake. Because you can 4 times say, yeah, 8 times -2 is -16 plus 9 is 4 if you put 4 here. You can talk yourself into the same mistake over and over. So start a fresh piece of paper, which is what I'll do. But when you send me your work, rather than just saying, I need help on that one, send me a picture of what you've got. It'll make it so much easier for me to find your boo-boo and you to then continue on. Okay, we've got a 1 here. We created a 1 in this column. We've got a 0. Now we're making this one be a 0. So to create a 0, it's a 2-step process. We're going to multiply the 1 line by the opposite of that coefficient. So I'm going to say -6, row 1, and then add it to that row, plus row 3. Okay. This is where I'm adding. The last thing I've written is the column that's going, is the row that's going to change. These two are not going to change, so I'm going to put row 1 in. I'm going to put row 2 in. And now I'm going to change row 3. I'm going to create a 0 here. So -6 times row 1, and it has to be built off of the 1 row, the one that you built, that you created a 1. That's where you're going to have to be multiplying times its opposite. So -6 times 1 plus 6, cool, got a 0 there. That's wonderful. -6 times -2, I'm continuing to multiply -6 times row 1. It gives me a +12, plus 0 is 12. -6 times 3, that's -18, plus 8 is -10. And then -6 times -4, that's a +24, plus 11 is 35. I believe that's we're not going any further on this, but let me see if I've got 0, I got a 7 there, yikes. Where did I, -892, -7. It's a -16. Yeah, so I've got a boo-boo in my other one, it looks like. I'm not going to explore that too greatly right now. So there might be an error in here. It might be in my other work. Let's look at what the next step would be. I'm happy with having just taken 3 steps with you. We created a 1 right here. Then we created a 0. Then we created another 0. Our next step then would be to make this one be a 1. We've got 1, 0, 0. Now we're going to scoot over and make this one a 1. Let's go ahead and figure out what that would be. If we're trying to make this a 1, it's a 1. When we're creating a 1, remember you want this diagonal line of 1s. It's a 1-step process. You're going to multiply times the reciprocal. So that will be a -1/7 times row 2. The reason why we're not going to continue this, I'll show you in just a second. If we're working with row 2, row 1 will not change. Row 3 will not change. Okay, but we will change the second row. 0 times anything will always be a 0. We're not going to, once we've created this 1, 0, 0, it isn't going to back up on us. It's not like a matrix cube or a Rubik's cube where you had them all right and then you turn it once and everything's messed up. This will maintain its, once we've done the work, we're not going to have to redo the work. -1/7 times -7 is a +1. And then these do not work out well. And so we're not going to continue on this one because this is way harder than our level at this point. But what we would do is negative 26 over 7. Negative times a positive is a negative. 26 is the numerator, 7 is the denominator, and let that ride there. And then a negative times a negative is a positive. You don't have to write the positive, I'm just doing that for emphasis. And then 32 is the numerator, 7 is the denominator. They will work out. Some of them will get really yucky before they get cleared up. And you'll wonder, if it's going to work out. We'll do one today where it gets messier before it gets dark, before it gets light. We're not going to take this further. So we've done 3-4 steps. Let's go to another one and do a couple of steps as just practice. Everybody hanging in there? Anybody losing their minds yet? There is no math skill here that you don't have completely comfort with. It's just different. Okay, let's see. Let me give you the augmented matrix of 1, 5, -7, -2. There. -2. And then 4, 3, 1, 8. -5, 2, 3, 7. Okay, we're only going to do 2 steps on this one. At least that's the plan. This is our last pretend one. The next ones we will do will be complete from beginning to end. We will solve them. Okay, creating a 1 in the upper left-hand corner. We've got that. So we're not going to have to create a 1. We've got it. That's cool. Next thing we want to do is create a 0 here. So let me remind you that creating a 0 is a 2-step process. We'll first multiply the 1 line by the opposite of the coefficient and then add. So I am going to multiply the top line times -4 because a -4 and a 4, when I add it to that, will work out beautifully and I'll have a 0 there. So I'm going to multiply this times the opposite of 4. 1 will be a -4 times row 1. That'll make that a -4. And then I'll add that to row 2. So row 2 is the one that is changing. I want to create a 0 there. So that's row 2 changing. You write the rest of row 1 and row 3 in there because we're working on row 2 right now. So -4 times 1 is -4 plus 4. Cool. Continue on doing that with row 1 and row 2. So -4 times 5 is -20 plus 3 is -17. -4 times -7, continuing on multiplying the top row times -4, gives me 28 plus 1. And then -2 times -4 is 8. 8 plus 8 is 16. Okay. So we got a 1. We got a 0. Keep going. That guy's got to become a 0. So we're working on row 3 this time. 1 and 2 will not change. This row will change. That will become a 0, and these will fall into line with doing whatever they need to do. So whenever you're trying to create a 0, it's a 2-step process. We're going to multiply the row 1 line. We're going to multiply that 1 line times the opposite of -5. And the opposite of -5 is a +5. So I'm going to do 5 times row 1. That'll give me a 5 there. And then add it to row 3. The last one listed here is plus row 3. So this is the one that will change. I'm not going to change the top 2, so let me just put my numbers back in. Okay, let's do our work now. 5 times 1 is 5, plus -5 is 0. Cool, we're there. We got what we wanted, 1, 0, 0. 5 times row 1 is 25, plus row 3, it gives you 27. Keep going. 5 times -7 is -35, plus 3 is -32. And then finally, -10 plus 7 is -3. Okay, if you got something different, please do holler as we do these, because I'm narrating as I'm going, anticipating, checking to see if anybody new has come in, all that. So I've got a lot on my brain, not ideal circumstances to do these. The math is super easy. You're not going to make a mistake because you don't know the math. You're going to make a mistake because your mind kind of wanders. Or if you're not good with negatives and positives, don't be good with them. Use your calculator. There's no harm in that. This is about principle, not about whatever. Okay, let's see. We've got a 1, 0, 0. We want to create a 1 here. Again, we're not going to go further than this because this is just a problem we're only taking 2 steps on, and we've already taken our 2 steps. But if we wanted to turn this into a 1, that's our goal, is to get a diagonal 1 here. We would multiply that guy times his reciprocal. His reciprocal is a -1/17 times row 1. That would, oh, sorry, times row 2. Times row 2. We're going to multiply, it's a 1 step. We're creating a 1. So we're multiplying that guy times his reciprocal. And that would create a 1 right there. And then a -29/17 there. And a -16/17 there. Row 1 would not change, row 3 would not change. We were just working on our 1 right here. We're not going to do that. We're done with this problem. Let's start our first problem where we're going to do everything. It's going to say use Gaussian elimination. So you know you're going to have to do the 1, 0, 0 thing. And on your test, you'll have where you won't have to do it and where you will have to do it. And it'll be pretty clear. You've got to show me that you learned this skill. Let's look at x plus y minus z equals -7. 6x minus y plus z equals -28. And -x plus 3y minus 2z equals 1. Okay. This is written in regular form with the variables in there. We want to first translate it into Augmented Matrix system. So build yourself a little construct there. Let's do 1. Oh, that's sweet. We've already got a 1 there. That's nice. 1, -1, -7. Fill the rest of this in. Well, I'm glad you're here, Adrian. We're just having a good time. Okay, so we've created this. We have a 1 here. Remember, our goal is to get 1, 0, 0. Then we'll scoot over on this column and go 1, 0. And then we'll finally scoot over on this column and make that a 1. And then the translation will be very simple with back substitution. So we've got a 1 here. Don't have to worry about that. Let's create a 0 here. So remember, a 0 is a 2-step process. You're going to build off of the 1. I'm going to multiply times the opposite of that. 6, his opposite is -6. So I'm going to say -6 times row 1 plus row 2. We're changing row 2. We're creating a 0 there. So if we are changing row 2, row 1 will not change. Row 3 will not change. Row 2, the last one written here, the bottommost one is the one that's going to change. So let's multiply -6 times row 1. -6 times 1 is -6. Add it to 6. Yay, we've got a 0. Let's keep moving. -6 times 1 is -6. -6 minus 1 is -7. -6 times -1 is a +6. 6 plus 1 is a +7. And -6 times -7 is a positive plus -28. That's just 42 minus 28 gives you 14 right there. Okay? So I got 1, 0. Oh, that one wants to become a 0. I'm going to rewrite this over here. Just copying it down. There's so many ways you can mess these up. I mean, you can start out by writing the problem incorrectly. You know, that's a way to mess this up. Copying when you go from line to line, that's another really good way of messing it up. Okay, we have a 1, we have a 0. This guy wants to become a 0. That's 2 steps. We'll build off of the 1. The opposite of a -1 is a +1. So I need just to take row 1, or you can put 1 times row 1 if you want to, plus row 3. Because 1 and -1 will give me a 0. When you are messing with row 3, the other 2 rows won't change. So I'm just going to copy them down there. Okay, 1 times row 1 is 1. 1 and -1 is 0. Woohoo! We are getting there, folks. We've got 3 parts in place right here. 1, 0, 0. We're next going to go attack that -7, but let's finish out row 3. So 1 times row 1 is a 1. 1 plus 3 is 4. 1 times -1 is -1. -1 and -2 is -3. And then -7 times row 1 is -7, plus 1 is -6. And again, please, if I make a boo-boo, holler. And if you're not certain and you look at it once and you still think you're right, say something. I don't want to go further. I don't want to go very far at all with a mistake on it. So I got 1, 0, 0. Let's make this guy be a 1 now. We're diagonally lining up 1s. So remember, creating a 1 is a 1-step process. Creating a 1 is a 1-step process. You multiply by the reciprocal. So let's multiply by the reciprocal of -7. That's a -1/7 times row 2. I'm going to be messing with row 2. I'm not going to be messing with row 1 or row 3. And anything we've already done will not be changed because, -1/7 times 0 is still 0. So we will not be altering anything that we've already put in place. -7 times -1/7 is 1. Woohoo! That's what we wanted to have happen. We want diagonal 1s right there. -1/7 times a +7 is a -1. And -1/7 times a +14 is a -2. Use your calculators and the ABC key on that if you need to. No shame in that. Okay, 1, 0, 0, 1, 0. We want this guy to become a 0. Remember, when you're creating a 0, it's a 2-step process. You have to work off of the 1 that you've created. I know there's a 1 there. Don't let that dissuade you. You have to work off of this line. So we're going to multiply the second line times the opposite of 4, and that's a -4. So -4 times row 2 plus row 3 will create a 0 there. It's always going to be the opposite of when you're doing a 0, when you're creating a 0. You want the opposite of that number. build off of the 1 line. Okay, we're going to alter row 3. The other 2 lines will not be changed. So let me copy them. And now I'm building a 0 here. So I'm -4 times, well, I don't have to worry about that. -4 times row 2, and you won't have to worry about any of these that you've already created. Don't even start there. Because, you know, -4 times 0 is 0, plus 0 will still give you a 0. So the constructs you've already built on the columns are good. -4 times 1 is -4 plus 4. Woohoo! Getting there, getting there. -4 times -1 is 4. 4 minus 3 is a 1. Oh, there's a gift. There's a gift. That's not going to happen every time. And then -4 times, where are we? -4 times -2 is 8. 8 and a -6 is 2. Why did you choose row 2 instead of row 1? It does matter, Chloe. It absolutely does. Let me take you back to the definition or to the strut. When you're creating a 0, it's a 2-step process. You have to multiply by the 1 line, the one that you created. This just happens to be a 1, but you can't go off of him because that's not a 1 that you created. You have to go off of the one that you've previously created. You have to go off of that line. It's just the way it works. So when we're building this, we'll be going off of this 1. When we're building these zeros, we'll be going off of that one. Yes, the one I just worked on. Yes, the diagonal line. Nothing else going on here matters. It's the diagonal line. So yes, it'll be off of this one that we just created, that we just built off of. And that's a huge important thing. Okay, let's look at what we've got here. Our goal is to get 1s on the diagonal, and we've got 1s on the diagonal right there. So we're done. We're done with this. We've got 1s here. We've got 0s here. We're done. Let's translate this back from XYZ form. We got into augmented matrices. Now we're going back into XYZ form. So we've got an X plus Y minus Z equals -7. Here we don't have an X. We've got Y minus Z equals -2. And here we don't have an X or a Y, but we have a Z equals 2. This is fantastic right here. There is one variable in one number, one equation. So we've got Z. So our answer will be XY2. Now take that and plug the 2 right in there. So we've got Y minus 2 equals -2. Just plugging in, build back up. Remember, this is called Gaussian elimination with back substitution. So we did the Gaussian elimination. Now we're doing the back substitution. We're substituting in backwards. So move this over, +2 gives us Y equals 0. So we've got 2 elements now, 2 answers, 0 and 2. Let's go back up into the original equation, put a 0 there, put a 2 there. So we've got X plus 0 minus 2 equals -7. Move the 2 over, the 0 goes away. So we get X equals -5. So there's our answer. Let me make sure that matches when I did it earlier. Good, yay, matches. That's a good sign. We can do it twice to get the same answer. So this is our answer right here. We started out in XYZ form. We translated it to an augmented matrix. We worked our way to where we had 1s on the diagonal and 0s over in the left-hand corner. And then we translated it back into XYZ form, got our gift, which we'll always have because these will be 0s. We'll have Z equals. We'll always end up with Z equals its answer that will then plug into where Y and Z exist. Once we get Y solved, we'll plug into where X and Y and Z exist. So this formatting will always happen once we're done. Okay, that's 1. We have 2 more complete ones to do. Any questions? Yeah, Rebecca.
When Chloe asked line 2, you said you always do the one that you created last. But if you go to step 3, you chose line 1, even though we created the...
You build off of the one that you created. Let me go back here. When you're creating a 0, must be the one line, multiply the one line by the opposite. You won't build off of the previous 0 ever. You're always building off of one lines.
But then you created off of line 2, and it starts with a 0.
When we were trying to create our next one, you mean once we got this one finished, this column finished?
No, the next step.
Okay. Then once we had a 1 here, and that's where we're going off of, is the one that we created here. Multiply this one that we created times its opposite and add it in here.
So it's not the line you created, it's the one that you most recently created.
Yes.
Okay, thank you.
Yes, it's the one that the one we did not create that one ever. That one just sort of happened to us. We were worried on creating that one, and actually in this problem that was given to us, doesn't matter. So when we come here and we're trying to build off, we're trying to get a 0, we're not going to be worrying about this one. We want to build off of the one that we created, not a one that just happens to be there. Okay, this is the first one we've done. You're not an expert here. You'll get to be an expert. Yes, absolutely. Yeah, you guys, you know, and I've probably said it before, you have questions that I don't have. You have questions that I don't understand sometimes. So it's always helpful, much more helpful in real life than here. This is such an artificial situation, social construct. But this is very helpful when if I'm not explaining it well enough that you continue to ask. Anybody else before we move to another one? Okay? And you'll see this gets infinitely easier as you go. Let's start with x plus 2y equals 0, x plus 3y plus z equals 1, and 6x minus y minus z equals 71. Okay, in order to play the game, you have to convert that into an augmented matrix. So let's see what we can do here. Oh, and these are used in anything where you produce a number, where you produce a final number, all kinds of electronics, all kinds of, oh, my husband was doing matrices by hand back in the dark ages, and reporting it. Well, he wasn't actually doing it. He was reporting it to somebody else when he was an intern and engineering, blah, blah, blah. But it's just used so much, and it's not just limited to 3 and 3. They can get huge. They can get as huge as you need. Computers now can do them, you know, 20 variables, 20 equations, can work that out quickly. We're not going to go bigger than 3 on 3. This is just so you can learn what's happening. Okay, so we got a 1, we got a 2, we got a 0, and a 0. Remember to put in zeros when they don't exist. Okay, that question that 2 of you had up here, I'm hoping we can straighten that out as we go by seeing another example. Okay, our interest is getting 1s in the columns there, in the diagonal column, and then 0s in this little corner here. So we have a 1 here. That's nice. We're not going to have to create a 1, but we are going to have to create 0s down here. So this is our 1 column. This is the one that we're going to be building 0s off of, no matter what these guys say we want to build off of row 1. So let's start with this guy. We need we're just multiplying. This is a 2-step process. In order to get a 0 here, we build off of this one. We want the opposite of that number. So -1 times row 1 will give us a -1. We'll add that to row 2. So -1 times 1 will give us -1. Negative 1 plus 1 will be a 0 right there, big fat 0, and that's what we want. So let's rewrite this. Row 2 is the one that's going to change. $71 there. So let's change this middle row. Negative 1 times 1 gives us 0. Sorry, negative 1 times 1 gives us negative 1. Negative 1 plus 1, that gives us 0. Continue on. Negative 1 times 2 gives us negative 2. Negative 2 and 3 is a 1. Then negative 1 times 0 is 0. 0 plus 1 is 1. Negative 1 times 0 is 0, and 0 plus 1 is 1. So we've got a 1 there and a 0 there. Let's continue on this column and make this guy a 0. Creating a 0 is a two-step process. We build off of the 1 in that column. So we're going to do the opposite of 6, which is negative 6 times row 1 plus row 3. And I'm putting row 3 down here on row 3. And you can do it anywhere. I used to just make it like math books do out here in the middle somewhere. But I don't think that's a bad idea to write them on their rows. Wouldn't you do row 2? Rows go sideways. Why would we do row 2? Are you sure, Chloe? Are you absolutely certain that that's a never mind?
Yeah, because we just made that 1 into a 0. I was thinking since the other two numbers were 1s that we changed them to 1s, but we didn't, sorry.
No, don't apologize. Please don't. So 1, 0, 0. Yeah, we want to finish this column out before we go progress over to this one and make then that 0 and then that 1. So we're working our way there. And I know this right now seems like I can't do this on my own. Yeah, you can. You will get there. It is a process, but there's no math involved that you can't do. I mean, I know you realize that. You all can realize that. There's no math that is going to trip you up. It is just the mechanics of it. So we're trying to create a 0 here. Negative 6 times that gives you negative 6. Oh, wait. All I'm going to do is change row 3, so let me put in everybody else. 0, 0, 1, 1, 1. Okay, now I'm ready to change row 3. Negative 6 times 1 is negative 6. Negative 6 plus 6, big fat 0. Good, look at that, 1, 0, 0. And even 1 right there. So we've gotten some help in this problem, but that's for the future. Let's worry on the rest. Negative 6 times 2 is negative 12. Plus row 3, negative 12 and negative 1 is negative 13. Negative 6 times 0 is 0, plus negative 1 is negative 1. And then negative 6 times 0 is 0. It gives us a 71 there. Let me rewrite that mess. Kind of scrunched it in there. Okay, I think that's a negative 1. Let me check it. Negative 6, yeah, plus negative 1. Okay, 1, 0, 0. We've tackled that. Now we need to go to the next column and make the next column. Columns go up and down just like a column on a building, and that'll be really crucial on Wednesday. We're doing, Wednesday. This, I know the math is easy, but the structure is hard. The process is hard. On Wednesday, everything is easy. It's so simple, but you do have to know rows from columns. Columns are just like columns on a building. Rows are like rows in a movie theater, if you can remember back that far. So we've got this column, 1, 0, 0. Then this is our next job, is to turn this diagonal into a 1, and he already is. So we're good there. Now we need to continue on down. We've finished this column. We're now working on this column, which needs to be, I don't care. This has to be a 1. This has to be a 0. So let's do a two-step process to create a 0 there. That two-step process involves building off of the 1 in this column, the 1 that we've created, the middle 1 in this case. Even if that were a 1, it wouldn't matter. We got to build off of this guy in our diagonal. So we want to multiply times the opposite. Negative 13, his opposite is a positive 13. So 13 times row 2 plus row 3, that's the 2 steps. We're multiplying times the opposite of this guy to create a situation that will give us a 0 there. Okay, row 3 is the bottom one written here. That means that's the one that's going to change. So I'm going to put in my other numbers. And now we've got, remember, this 0 will never change. 13, row 2, 13 times 1 is 13, minus 13 gives us a 0. 13 times 1 is 13, 13 minus 1 is 12. And then 13 times 1 is 13, 13 plus 71 is 84. So we've got 1, 0, 0, 1, 0, and let's create a 1 right here. We'll have our diagonal column, and then we'll be able to convert back into XYZ form and solve. So whenever you're trying to create a 1, it's a one-step process. You're multiplying that guy times his reciprocal. So we will multiply the entire row, which is just amounts to these two guys, times 1/12. Everything else stays the same on the other 2 rows. 1/12 of 12 is 1. That was our goal, to get the diagonal ones. And then 12 goes into 84 7 times. You can do that on your calculator. 84 times 1, ABC 12. Okay, once you've got the ones in place, and you've already done 1, 0, 0, 1, 0, and 1, so you've got the diagonal ones, and these are zeros, as you created them as you went, then we're done. Let's translate this. This is, let me put it here, it's easier. X plus 2y plus 0z equals 0. This has no x, so this is y plus z equals 1. This is z equals 7. So there is our answer to z. So where did these two cross? These three lines cross. They cross where z equals 7. Plug in a z right there. So we get y plus 7 equals 1. Move the 7 across. We get y equals negative 6. And then take both of these up to here. Well, we don't have to take the z. The z isn't involved in this, which is fine. So x plus 2 times negative 6 equals 0. So x equals 12. So we get 12, negative 6, 7, which good is the same thing I got last time I did it. So 12, negative 6, 7 is the answers that will work here. And I want to remind you that, if this is one of your answers, you can plug in, you don't have to do any of this. You can plug in 12 for x, negative 6 for y, 12 for x, negative 6 for y, 7 for z, 12 for x, negative 6 for y, 7 for z, and all of these will come true. None of the other choices on your test will work. So you will know which one works. If you get this problem correct, I'm going to go and I'm going to make sure you have shown me the matrix progression. The matrix progression is going to match mine exactly. There's no two ways to do these problems. If you don't have the matrix progression, even if you get the answer right, yay for you. You've got the skills to figure out how to cheat, in quote marks, totally quote marks, on a multiple choice test. And that is a valuable skill. There's no doubt about it. But I need to see that you know how to, not just how to plug in numbers. Plug in numbers is back in, 6th, 7th grade. I want to make sure that you can do matrices. So you're going to have to show me the proof, and I will check them, and I will take points off. If you have gotten the answer right, I'll take them all off without showing me the work. And this is the work I expect. There's nothing less here See, if we try the metric, mess it up, and just can't figure it out, we still get counted wrong. Yes. Yeah, I'm giving you, I might give you partial credit, Rebecca. I mean, I get it that if you get stuck on one little bitty thing and can't figure it out, but you've got the process, that's what matters. So if this is worth 4 points, I'll give you 2 or 3 points, that kind of thing. But the skill that I'm testing is, can you do this? So if you can't do it, you can't do it. You know, you don't get points for not doing something that you can't do. But I understand what you're saying. If you try it and you can't get it to work, you still have the skill. You're just making some dumb bunny mistake, like writing the problem down incorrectly. Watch out for that. Okay, let's do another one. This is our last full one. 3x minus 8y minus 2z equals -8. 2x plus 6y minus 5z equals 14. And x minus 2y equals 2. Okay. Translate this first. Don't forget to put in a 0. This example is here to show you that you can move equations around. Look, I've got a 1 right there. I want the 1 up there, so I'm just going to move it. Remember, it's just taking this equation and moving it to the top. That's all you're doing. So I'm going to rearrange my equations to suit me. And then I'll put the 3 next. Doesn't really matter at this point. But heck, I need a 1 right there in the upper left. This guy, just move him up to the top. Make sure you move all of them. X, Y, Z equals a number. The entire equation moves up to the top. Okay, so we have a 1. That's cool. Now we want to create a 0 here. Creating a 0 is a step process. I'm going to build off of the 1. The opposite of 3 is -3. So I'm going to say -3 times row 1 plus row 2. That's going to create a 0 right there. I know that only row 2 will change here. And let's go change row 2. -3 times 1 is -3 plus 3. Wonderful. -3 times -2 is a +6. +6 and a -8 is a -2. -3 times 0 is 0. Plus -2 gives me a -2 there. And a -3 times 2 is -6. -6 minus 8 is -14. Adrian, you missed kind of the building blocks of this. Is this driving you nuts, or are you kind of okay with this? Okay. Let's see, we've got a 1 there, we've got a 0 there. We want to create a 0 here. That's a 2-step process. You want to build off of the 1 that you've created on the diagonal. In this case, that guy right there. So the opposite of 2 is a -2. So I'm going to multiply 1 times -2 and add it to row 3. So I know that nothing's going to change on row 1. Nothing's going to change on row 2. -2 times 0 is, -2 times 1 is -2. -2 plus 2 is 0. Look at how we're creating this situation that's going to help us out. Continue on doing the rest with row 3. So -2 times -2 That's a positive 4. 4 and 6 gives you 10. Negative 2 times 0 is 0, plus negative 5. Negative 2 times positive 2 is negative 4. Negative 4 and 14 gives us 10. You can miscopy right here and it throws everything off. So just be careful. Okay. One, zero, zero. Next, we want to work on our diagonal. I want to create a 1 there. Creating a 1 is a one-step process. We multiply times the reciprocal. So the reciprocal of a negative 2 is a negative 1/2. Negative 2 times negative 1/2 will give us a 1 right there, and that's working on that diagonal line. I'm only changing row 2 here. Negative 1/2 times negative 2, wonderful. Negative 1/2 times negative 2, another 1. And then negative 1/2 times negative 14, that'll give me a positive 7. Okay, 1, 0, 0, 1. This guy needs to become a 0. When you're creating a 0, that's a two-step process. You build off of the 1 that you just created. The first part is to recognize that 10, its opposite is negative 10. So negative 10 times that 1, remember it's always going to be a 1 there, negative 10 plus row 3. We're changing row 3. The other rows will stay the same. The 0 that we created will remain the same. Negative 10 times row 2, that's negative 10 times 1 is a negative 10 plus 10. Good. 1, 0, 0, 1, 0. We're almost there. Negative 10 times row 2, so negative 10 times that one, negative 10, minus 5, that's negative 15. And then negative 10 times 7 is negative 70. It's going to give us negative 60 there. We want to make this guy be a 1. We've got 1, 0, 0, 1, 0, and now diagonally we need this to become a 1. Creating a 1 is a one-step process. You multiply this guy times his reciprocal. So I'm going to multiply negative 115 times row 3. I'm changing row 3, so these others will stay the same. If we multiplied it times a positive, we'd have a negative times a positive, and we'd get a negative 1 there. And you need this to be a positive 1. So you want negative times negative. That'll give you a positive 1. So the reciprocal will keep the same sign. You okay with that, Chloe? Okay. So negative 1/15 times the negative is a positive. 15 times its reciprocal is a 1. Negative times a negative is a positive here for the answer. 15 goes into 60 4 times. Once you've got the 1, 1, 1s going, and these will be zeros because you will have created it by column, you're done. Let's translate it back. X minus 2y equals 2. y plus z equals 7, and z equals 4. There we go, z equals 4. That's good news. Let's plug that back in here. Y plus 4 equals 7. So y equals 3. That's cool. Take both of these. X minus, I feel like I just did this. Is this, there's no way we did the same one twice. No, we didn't. Okay. That would be bizarre. Equals 2. So x minus 6 equals 2. So x equals 8. And there's our answer. 8, 3, 4 for the 3 answers. Okay, questions on this one? Okay, the last one we're going to look at is we're not taking it all the way through. In fact, we're not taking it through anything. Let's say that you get 1, 0, negative 15, 12, 0, 1, negative 10, 10, and 0, 0, 1, negative 1/5. They're going to give you a problem where they're saying this is the end result that you get. You've done the Gaussian elimination. You've got 1, 0, 0, 1, 0, and a 1. So you're at this last step. You're like at this finished step here, and you're just now left with translating it. So let's translate what we've got here. X, no y, minus 15z equals 12. Here we've got y minus 10z equals 10, and z equals negative 1/5. So there's the z, negative 1/5. Let's figure out the x and the y. Let's plug them in. So we're going to take this z and plug it in right there. So we get y minus 10 times negative 1/5 equals 10. So grab your calculator if you're not comfortable doing the fractions. We've got negative 10 times negative 1 ABC 5. That gives us a positive 2. So y plus 2 equals 10. So y equals 8. So I got 8 is y right there. Now let's go after this last equation. X minus 15 times z, z is a negative 1/5, equals 12. So x, negative times a negative is a plus. 5 goes into 15 3 times. So x equals 9. So we end up with 9, 8, negative 1/5. So you have a little bit of a nasty there, and they just ask you what happens then. They want you to get in practice multiplying a whole number times that fraction. Okay, that is section 6162. I want to do 2 more things with you. I want to go over what we're looking at for this, this week, and then I want to take you on a mini tour of how to sign up for fall classes. Don't think that's a bad use of our time in here. So look at this. We've done 5-1, 5-2, finished 5-2, 5-4, 5-5. We've done 6-1 and 6-2 now. 6-3 is the easiest up to that point, but we'll have more easy. Chapter 8 is super duper easy also. So 6-3 on Wednesday is on a worksheet. I've put that worksheet at slides. Very simple stuff that we're going to do on Wednesday. Then we'll finish up in a couple of weeks. End of the month, you'll take your test. We'll review this whole week. We'll review on Monday, all day Wednesday, and then I'm hoping that you'll have Wednesday, Thursday, Friday to take your final. We haven't gotten instructions on that, but that would be compatible with what we had for instructions last semester. So we will plan on a regular kind of thing where you finish up your final. We review on Wednesday, and you have Wednesday, Thursday, and Friday to take your final. Okay, let's see if I can do this. I don't know if my computer's going to freeze, but let's go and find how to register for classes for fall. You want to get to There are lots of ways to do this. I'm going to, let's see, let me share my screen. Looks like I'm going to be able to move. I don't want to do that. Let's see. Share application screen, Chrome tab, Blackboard Collaborate. Okay. I'm going to get there by going back to Web Advisor, going to Web Advisor here on Blackboard. There are lots of ways to get to where you need to be, but this is one of them. So I'm going to click on Web Advisor. And now I have decided to freeze. Great. So you'll click on Web Advisor, and then it takes you to, boy, that is not useful. Here we go. Here we go. It's opened up another screen, so let me go back and move you to that. Okay, let's stop sharing that, and here we go. And then My TC track registration, click on that. And then go to student planning. Right here is student planning. There's lots here. There's tons of good stuff here. This is a really good, useful website for students. But to get to classes, and then up here I'm going to search for courses. You can see I've already searched for a couple of them. Let's go to math first. You can put anything in there. You can just put math if you want to. Let me hit enter. And then here's the biggest deal. On the left-hand side, I've got fall 2021 with 46 sections of something showing. I don't know. I'm going to filter for just that. An hour and a half ago, Rebecca and I were working with this, and she didn't have fall there. Rebecca, are you keeping up? Do you have fall now?
My legal
Anything?
classes are showing fall right now, so and possibly all classes for fall are just slowly cycling in.
I agree with that completely. They are filtering them in. They should have had it all available this morning at midnight, but didn't. So I'm going to filter just for fall. And then I'm looking at college, this class. If anybody knows what this course is planned means, I would love to know what that means. View available sections, click here. And then what will drop down is all the ones they have put in so far. You can see 25 seats, instructor is listed there. Let's see. Alexander, I gave somebody, Umberto, I gave them, I looked at that. Anyway, that's a good instructor. You don't need these classes. These are not your classes because you're taking this class and you're doing well in this class. I'm just looking down here, Griffin, he's one of our instructors. He's a wonderful instructor. There's me, there's one of my classes for fall, and there's my other one. So I know that some of these classes have filled in. I just saw somebody said something, let's see. I think planned means you put it down. Oh, so you can click that and it will go into your plan. No, there's no, oh, because I got you, Amanda. I got you. Okay, so since you're here, Amanda, let's look at that. What is that you wanted pre-cal? You were looking at pre-cal. So let's, let me pull this one. I don't want to look at that anymore. So let me click that back up. You go down to where pre-cal is. So that's how you get it there. And then here is the one that Amanda wants, and Giovanni is looking at that too. View available sections. Let's see how many we've got. We got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's probably, I wouldn't be surprised if that weren't all the sections available for fall. So, you know, you look at the time, the campus matters now because we will be face-to-face. So it matters what campus. So if you are looking for our campus, you're going to go down here, and you could have filtered for that also. So Northeast Campus, Kim Brown is teaching. Kim Campbell, I am in love with Kim Campbell. That's who you need to take. Amanda is worried about that. Giovanni's not here right now. Kim Campbell is incredible. You will watch her numbers go down starting May 3rd. They will go down much more quickly than some of these others that I'm seeing here. Yeah, and this is Northeast Campus also, Northeast Campus, Northeast. Yeah, I don't usually know. This dude is brand new to our campus. He's great. Oh, Jennifer Anderson, I love her too. If you're a Northwest person, Jennifer is a wonderful teacher. So for your question, Amanda, I would recommend Kim Campbell completely. She is the one to take for Northeast Campus. Are you going to be on the? Go ahead.
No, I don't go to Northeast. I go to Trinity. But I mean, if I have to travel to take a good teacher, so be it.
Well, you know, you've got Rate My Professors that you can go to. You can look at Rate My Professors. Let's see. Let me see what I can find about Trinity. These aren't in alphabetical order, and I didn't filter for that. That would be smart to filter for Trinity. Southeast. There's Trinity. TBD. That's not helpful. TBD. So they haven't even there. Kristen Hemingway. Take Kristen. Take Kristen Hemingway. She used to be an adjunct at Northeast. I knew her for years. We get together for lunch sometimes. We haven't since she's been department chair. But that's who you want to take, without a doubt, Kristen Hemingway.
Okay.
I'm so excited for that, and I will let her know that you are taking her class, and you will love her, and she will love you. She is a wonderful instructor.
Thank you.
When you said Trinity River, I was so hoping she was available and teaching that class, because she's the only one at Trinity River I know, which is part of it. But you will. Those are really good teachers. Kim Campbell at Northeast, Jennifer Anderson at Southwest, and Kristen Hemingway at Trinity River. They all care about students, which is, kind of a quality you want in your instructor, is that they care. Okay, I am going to stop